for our first presentation, Dr. Eric Landis is a professor of civil and environmental engineering at the University of Maine. His research is mostly on experimental mechanics and fracture, with particular focus on the use of innovative laboratory techniques to solve problems of fracture and failure in cement-based, wood-based, and composite materials. At the University of Maine, he has been honored with both teaching and research award. And in 2002, he was presented with the University of Maine Presidential Outstanding Teaching Award. Congratulations. And in 2004, he was a distinguished Maine professor. And in 2006, he was the Carnegie Mellon U.S. Professor of the Year in Maine. His presentation is titled AI-based advances and UAV-based bridge inspection. So, Eric.
All right, thank you for that very kind introduction. All right, I think I'm going to try to do the impossible, which is talk about all the things that we can do with drones in less than 10 minutes. But before I do that, I definitely want to acknowledge the PhD student Zahra Emeli, who the actual research that I'm going to present was all done by her. So just bring us all up to speed. Why drones? You're going to see that the most frequently cited use are the most cited reasons for using drones: reducing costs, efficiency, and safety. I think this one captures all of them. Certainly, as far as reducing costs, I don't know what these guys get paid. I'm sure it's not enough. And the efficiency and safety become quite apparent. The other one that you often, I think any drone manufacturer who sells to the bridge inspection industry has shown this picture, because then that basically it sells the product for themselves. All one has to do is picture themselves sitting in the bucket there. So briefly, the reducing costs, the typical number cited for the cost of a bridge inspection is about half of that cost is to closing the road, closing traffic, and the traffic safety part of it. So right away, 50% of your cost is gone, and you haven't even looked at the bridge. So with respect to the cost of efficiencies, quite straightforward. Efficiency, you can cover a lot of territory in a short amount of time. And of course, here's this picture illustrates the safety. So the most common applications right now for bridge inspections is just the rapid collection of high resolution image data. The image data could be optical image, it could be infrared. There are various types of image data that can be collected. But also, we can easily move around to spaces that we couldn't easily see before, specifically underneath the bridge. This is due to recent advances in drone technology, where it used to require GPS, access to GPS to fly for the navigation, which made it a little tricky going underneath the bridges. But with new guidance systems, this is fairly straightforward. This is now very obsolete data, but this is about 2018. All of the states that are applying drones in some form of transportation, could be bridge inspection, could be traffic monitoring, could be other applications. Just in the 2 years from 2018 to 2020, go from this little, so now this is the bridge inspection, relatively small percentage to a growing percentage. The other aspect of the rise, what I'm calling the rise of UAVs, is just in the research community. In the literature in structural health monitoring, now a huge jump in the 10 years between 2010 and 2020 in how much effort was going to these automated systems for monitoring structures. So what is the current practice? That is, what are state DOTs currently doing in conjunction with their consultants? Primarily visual inspection. You can inspect a bridge very quickly, running a drone across it, get very high resolution, as I mentioned, high resolution data very quickly. That can be combined with thermal imaging, which gives you a imperfect, but an idea of what might be going on underneath the surface of the material. A lot of work right now, actually in form of as-built surveys or just other condition assessment in LiDAR-based scanning, that you can get a three-dimensional as-built model of the structure. Now, what's being used less, but starting to emerge, some very exciting things. First of all, what we're calling autonomous navigation and flight plan. Okay, instead of actually showing up with the site, showing up at the site, and then just having your pilot fly around, you can pre-program this ahead of time. So might want to, for a particular bridge, you might want to optimize how you fly along, vertical, horizontal, and that's done all automatically. Okay, then combining different images. As I said, we had the fusion of different sensor types is kind of the emerging field. Now, AI in the title, AI is everywhere, and what this comes down to is data. With these new sensing technologies, well, new for maybe not new, but for the past 10 years or 20 years, we've been able to collect data faster than we can process it. Okay, so where the AI comes in is now we're in a position to catch up. If we've got to look at gigabytes of data coming off of a bridge, that provides a huge bottleneck for the inspection. Whereas if we can automate much of that, which we can, that can be, and that could be in the form, what I'm going to talk about in a moment is the processing images, but that could be also processing vibration data, all kinds of other information that might be coming off of a bridge. And what's coming, of course, this is the rise of AI is going to take care of a lot of things in a way probably 10 years ago we never would have imagined. Obviously, the automation is what I just described. New integration with building management and GIS. Drones are coming faster, lighter, being able to carry a broader array of sensing packages. Wireless charging stations, actually in the wind energy industry, we're seeing more in the case of a parked drone on the site that can be actually flown remotely by somebody in the office using virtual reality and augmented reality. And then, the ability to rapidly analyze this. So very briefly, something we're doing on TIDC funded projects is some of this rapid analysis of image data. In this case, corrosion detection. This is actually not a straightforward problem because some corrosion could just be superficial, some is quite severe, other is actually desirable. So how do we train the drone to be able to recognize these different characterizations? So what we've been doing here, just like training students, we have to train the algorithm to be able to identify to look for different features. So what we recently put online, Zara analyzed about 500 different pictures for the depth of corrosion, ranging from the AASHTO standards of fair, poor, severe, and to be able to train the algorithm to recognize those. And all of these are online now. You can download them and see both the raw images, but also how they've been annotated for training the network. So here's an example where we have the original images of some segment of a bridge, ranging from the fair, poor, severe, and several different algorithms for identifying and classifying You can't really see it, but the algorithm actually identifies a segment, classifies it either, in this case, fair, poor, severe, and then gives a weighting or a confidence, I'll call it, to how just how confident the algorithm is that yes, this is fair, this is poor, and this is severe. So the next step here will now, the algorithm is quite successful, but now we've got to be able to integrate it into the protocols for the bridge management systems and data management systems. So in that whirlwind, no pun intended, tour, hopefully I showed that we're making already, drones are making a big impact on infrastructure. Certainly mentioned AI algorithms coming on the scene very fast. The next steps will be get these AI-based analysis into the infrastructure management systems. So I think my time is up. Thank you.